Section 15D, question number 4, page 371. Part A is asking us to verify that the derivative equals a certain function given that y is x squared minus 3x plus 1 all over x plus 2. So I have to differentiate this and find the gradient function. So I will go ahead and use the quotient rule to do that. So there's nothing really, or actually there's nothing to rewrite there, so I'll just go ahead and take the derivative. So I take the derivative of the numerator, which is 2x minus 3, multiplied by the denominator, which is x plus 2, minus the numerator, which is x squared minus 3x plus 1, multiplied by the derivative of the denominator, which is just 1. And this is all over the denominator squared. Now, normally I would leave things in factored form, but in this case the question asks that we verify that the derivative is in a certain form, and that form is an expanded form, so I'll expand this out here. So 2x times x gives me 2x squared plus 4x minus 3x minus 6, and then that 1 doesn't really do anything here, and then I'll just multiply that 1, or the negative 1 in, so negative x squared plus 3x minus 1, again all over x plus 2 squared. And I'll just simplify the numerator by collecting all the like terms. So 2x squared plus or minus x squared is x squared. 4x minus 3x plus 3x just leaves us with 4x. And then negative 6 minus 1 is negative 7. All over x plus 2 squared, as required. Part B is asking us to find the values of x where, in part 1, dy by dx equals 0, and dy by dx is x squared plus 4x minus 7 all over x plus 2 all squared. So if we set that equal to 0, then we can start solving for x. So I'm going to multiply both sides of this by the denominator, and of course this denominator, x plus 2 all squared multiplied by 0, just gives us 0, so we're left with x squared plus 4x minus 7. When I try to factor that, I'm not successful in just factorizing, so I'm going to use the quadratic formula, and that quadratic formula, just as a little reminder, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. So I'll substitute all those values into this formula. So x equals negative 4 plus or minus 4 squared minus 4 times 1 times negative 7 all over 2a. Then I get negative 4 plus or minus, there's 16, negative 4 times 1 times negative 7 is 28, all over 2, and then I get negative 4 plus or minus 16 plus 28 is root 44, all over 2, and I will make this root into a mixed radical, so negative 4 plus or minus, that's 4 times 11, and then when I take the square root of 4, see that is actually root 4 times root 11, so that thing is there. So therefore I can take the square root of 4, so I get negative 4 plus or minus 2 root 11 all over 2, and then I can simplify that to give me, and I'll break it apart here, negative 2 plus root 11, or x equals negative 2 minus root 11. So those are the two values of x in exact form that will produce dy by dx equal to 0. Part 2 of B asks us to determine when dy by dx is undefined. I'll just use a little short form here, undefined. And that occurs when the denominator of the gradient function equals 0. So I've got x plus 2 all squared equals 0, because we know we cannot divide by 0. I'll take the square root of both sides to get x plus 2 equals 0, and then I will subtract 2 from both sides to get x equals negative 2. So dy by dx is undefined when x equals negative 2. Now the last part of this question, C, asks us what is the graphical significance of the answers in part 1 and 2 here of part B. And so when dy by dx equals 0 for part B, we have a turning point, because at that turning point the tangent to the curve is horizontal. So we have a horizontal tangent, and we know that the gradient of a horizontal line is 0. So, and we know that the gradient function is the gradient of the tangent to the function, so that's a horizontal tangent, and therefore the turning point indicates a local max or local min. And for part, that was part 1, and then for part 2, it's undefined, which means that there is a vertical tangent. At that point.